Happy Dewey Decimal System Day. Just as an FYI, I don't know the schedule for club pictures this morning. So if you do have a club picture between now and 8:55, just get up and go. Okay, right? You know, I get it. It's picture day. It happens. Okay, so just know that yes, we are obviously here today, and so we'll do proving trigonometric identities today. We'll finish that up tomorrow, and then Friday will still be your formative. Okay, so the plan really didn't get altered because school didn't get altered, so we're fine with that though. Not mad at all. Okay, so this is an algebraic identity. Okay, so this is, and we're going to have something that looks like this, except it's going to have lots of trigonometric things in it. And the kicker is that it is a true statement. Okay? All of the things that we're going to tell you this week are true statements. Okay? So when I say that x squared minus 1 divided by x minus 1, subtracted, and then minus x squared minus 1 over x plus 1, when I say that, that truly is equal to 2. Okay? You just have to prove it. Okay? And in order to prove it, you can only, and I say this because you're going to try and not do this, but you can only work one side. Okay? You can't work both sides. You can only work one side. And you have to get that one side to be the other side in order to prove it. Okay? Now, you're going to ask numerous times, which side do I choose? Okay? And you have to look at the problem and you have to say, okay, what side scares me the most? And that's the side you choose to work. Okay? Because if it's more, the scarier that side is, the more you can do with it. Okay? So if I'm looking at this algebraic proof, I'm looking at the left side and I'm starting to get a little shaky. Okay? The other side is just 2. There's not a lot that I can do with 2. Okay? So I'm not going to work the right side. I am going to choose to work the left side. Okay? So I am only going to look at the left side. I am not going to look at the right side one bit. And I know that I'm done when I have simplified the left side and the only thing that I have left is 2. Okay? So this is where we're going to start. Let me put it in, we'll go in pink because it's Wednesday. So this is my start, and I'm only going to work that pink box, and my end is right here. That's how I know, oops, I should have put that in a different, come on, work for me here. That's how I know that I'm done. I made that pink box become 2. All right, well, let's do it. The other thing about this is if you think it, it's got to be written down. Okay? We're not doing anything in our head that we don't write down on paper. Okay? So I would look at this and I would say x squared minus 1 factors into x minus 1, x plus 1. Would you agree with me that x squared minus 1 factors into the x minus 1, x plus 1? Okay. Now, I can cancel out this x minus 1, cancels out that x minus 1. This x plus 1 cancels out that x plus 1. And I've shown it. And then I would write that. Because I got to write everything down. Then I would distribute this negative sign into there. Then this positive x cancels out, it gets canceled out by that minus x, leaving me just with 1 plus 1, which is 2. Come on, work for me today, there, Ben, of the Q's. And now I know that I'm done because I have simplified my pink box all the way down to 2. And now I know that I can stop because I got the other side. With me? Let's try a trigonometric one. Okay? Again, I remind you, and for the new bodies that just came into the room, we are proving so we can only work one side. Okay? We're picking the more complicated side. Okay? We cannot do something to both sides. Bless you twice. Okay? We cannot do something to both sides because we are only working one side. And I will also tell you that adding and subtracting is more complicated than multiplying and dividing. Okay? Adding and subtracting is more complicated. So therefore, in this particular one, the side that I'm going to choose to work is going to be the adding and subtracting side. So I need to get tangent plus cotangent to become secant cosecant. Okay? Well, what do we know about tangent? Thank you for learning yesterday about what it's not cos or cos, whatever you were saying yesterday.
Sorry.
That's okay. It happens. It is sine of x over cosine of x. Okay? What do I know about cotangent?
Cosine over sine.
It's cosine of x over sine of x. Okay? I have two fractions that I need to add. What do I need to have in order to add them? Gotta have a common denominator. What would my common denominator be? Cosine of x, sine of x. So in my first one, I started with a sine of x. What am I missing?
Times cosine?
Nope.
Oh, times sine.
Times sine, yep. Because I started at cosine, now I'm at cosine sine. So I need another sine of x. In my left one, or excuse me, my right one, I started with a cosine. What am I missing? Went from sine to cosine sine. So I'm missing a cosine. Okay. One of those days where the screen just goes black. Okay? So then this becomes sine squared of x over cosine of x sine of x plus cosine squared of x over cosine of x sine of x. Agree with that? Now I can add the tops. And I have to show that. Now what can I do? No, I cannot whack off the cosine and whack off the sine. No, I cannot.
Oh, because of addition.
Because of the addition. Yep. So what can I do?
Change either sine or cosine to their counterpart.
Could do that, but there's a quicker way.
Use the hammer.
So the top, the numerator is equal to 1. Yep. So the numerator, sine squared plus cosine squared is just 1. So I can just go right to that.
Oh.
I don't have to change one of them and then do an extra step. Okay. Would you agree that this fraction, 1 over cosine times sine, is also 1 over cosine times 1 over sine? Would you agree with that statement? Yeah? Okay. What is 1 over cosine? That's secant. What is 1 over sine? That's cosecant. And now I have the other side. So now I'm done. Okay? We work that one side, that scary side, that one that gives us nightmares. We work that side until we get the other one. And then you know you're done. If you don't get the other side, you are not done. Okay? Right? People have asked all last week when we were simplifying, how do I know when to stop? Now we're telling you when to stop because we're telling you what you need to get. Okay? Let's try one on your own. Try that one. So first thing that I would do, which side am I picking? Which left side? Yep. Okay. I would agree with that. So then this is going to be the sine of x times, I would change cotangent into cosine of x over sine of x. Then I would change cosine, or I wouldn't change cosine, excuse me. I would change tangent into sine of x over cosine of x. Agree with me on those two changes. Yeah? Okay. Then I would simplify and I would say this is the sine of x times cosine of x over sine of x plus sine of x. Agree with me on that? Where I took this cosine and it canceled out that cosine. Would you agree? Okay. Then I would distribute this sine. If I distribute that sine, then I get cosine of x plus sine squared of x, which is what we were looking to get. Questions, comments, concerns, clarifications? Try that one. So if I'm working the left side, I would say secant is 1 over cosine plus tangent. Tangent is sine over cosine. Agree? Okay. So that's already in common denominator. So then that would be 1 plus sine over cosine. Agree with me on that? Okay. Now, I could make this be, because I see, just because I can't work the other side, I can still look at the other side. Okay? And on the other side, I see that there's a cosine on the top, so I'm going to introduce a cosine on the top, which means that I have to multiply by 1, so I need to multiply that fraction by cosine over cosine. That then gives me agree with that. Okay. I can use my trig identities and I can change cosine squared into 1 minus sine squared. One minus sine squared is 1 minus sine, 1 plus sine. And now both of these cancel each other out, and that leaves me with cosine of x over 1 minus sine of x, which is what I needed to get to. Okay? That's working left side. If you're working the right side, I would say that I would multiply here by 1 plus sine of x on both sides. That then gives me that. One minus sine squared is cosine squared. The cosine on the top cancels out one of the cosines on the bottom, leaving me with 1 plus sine of x over cosine of x. Which could then be written as 1 over cosine of x plus sine of x over cosine of x. I can break up the numerator. I can't break up the denominator, but I can break up the numerator like that. 1 over cosine is secant sine over cosine is tangent. Okay. Doesn't matter which side you work, but you can only work that one side. Okay? You can only work one side to get the other side. Can't work both sides at the same time. Okay. Questions? Try that one. I'll start again, left side. If I'm looking at the left side, secant squared minus 1 is identity number 11, and that is just tangent squared. Tangent squared is sine squared over cosine squared divided by sine. Keep change flip would make that become sine squared of theta over cosine squared of theta times 1 over sine of theta. 1 of the sines from sine squared cancels out that sine. So then we're left with sine of theta over cosine squared of theta. And cosine squared of theta, according to number 7, is 1 minus sine squared of theta. If I was working the right side, I would say here then first, work that in black. Did I do that first? No, yeah. Okay. Brain fart there. I would say that this is sine of theta divided by cosine squared of theta. Yes? Okay. Seeing a sign on the bottom, I'm going to introduce a sign on the bottom. Sine of theta over sine of theta. That then becomes sine squared of theta over cosine squared of theta sine of theta. Which is the same as sine squared of theta over cosine squared of theta times 1 over sine of theta. Sine squared sine squared over cosine squared becomes tangent squared. Over sine of theta. Tangent squared from number 11 is secant squared of theta minus 1 all over sine of theta. With me? You now have the ability to do all of the homework. Okay? Homework packet is wide open. Okay?